Hey everybody, here is the cone situation we were working on in class today. I have the notation set up a little differently this time, mostly so that the numbering of my R's and L's match. So we have this big cone, and the length down its side is L1, and the radius of the big cone is R1. The band of this big cone that we want is given by this red piece at the bottom. The length of this little red piece is L, and the part of the big missing tip of the cone, its radius is R2, and the length down the side is L2. We worked out in class that the area of the side area of a cone, so not including its base, is pi times the length down the side times the radius of the base. And so using this area formula, the area, oops, let me get white. The area of the just the red piece down there, area of the band along the bottom produced by this red piece is the side area of the big cone, which is pi times the side length of the big cone, which is L1, times the radius of the big cone, which is R1, minus the area of the missing tip of the cone, which is pi, since that's also a cone, it's pi times the side length of that cone, which is L2, times the radius of that cone, which is R2. Okay, so let's start out by factoring out the pi. We get L1 times R1 minus L2 times R2. And to make use of all of the relationships in this triangle that we're seeing, what we need to do is get, so you see there's a very small triangle right in here. And that one is similar to the big triangle here. Okay, and the bottom side of this small triangle is R1 minus R2. So to make use of the fact that these triangles are similar, we actually need to get R1 minus R2 into the game. And we have an R1 here, so we can make R1 minus R2 appear like this. It's a bit of a cheap trick, but we have R1 minus R2 plus R2 again. And then minus L2 times R2. Okay, so now we have the R1 minus R2 that we wanted, or that I claimed that we wanted. So let's distribute this L. Oops, this is supposed to be L1 here. Distribute this L like that, and we get L1 times R1 minus R2 plus L1 times R2 minus L2 times R2. Okay, and now in these second two terms here, these guys, they have an R and R2 in common, so we can factor out R2 from there. We get pi times L1 times R1 minus R2 plus R2 times L1 minus L2. Like this. Okay, so now we have the piece right here, R1 minus R2, that we thought would be useful for similar triangles. So let's write down similar triangles to see what we get. So using the small triangle here, the very small triangle, I accidentally resized my brush, as I often do. There we go. Using this small triangle, the bottom side is R1 minus R2. And the diagonal side is L1 minus L2. It's also called little r, but for now let's call it L1 minus L2. Okay, so on the big triangle, the bottom side is R1, and on the big triangle, the diagonal side is L1. Okay, now clearing all the denominators from this, we get L1 times R1 minus R2 is equal to R1 times L1 minus L2. So what this is showing us is over here in our expression for the area of the band, L1 times R1 minus R2, that's in our similar triangles equation, we can replace that with the other side of our similar triangles equation. So we get pi times R1 times L1 minus L2 plus R2 times L1 minus L2 okay, now we're almost to something that will feel good once we get it. This pi times, now if you look here we can factor out this L1 minus L2. So L1 minus L2 times, the stuff that's left over is R1 plus R2. And remember, L1 minus L2, we called that little l. So little l times R1 plus R2. So this seems pretty good because this expression for the area of that band only has the dimensions of the band in it, the 2 radii and also the slanted side length of the band. As sort of a finishing touch, people will often multiply and divide by 2. So they'll put a 2 times 2 there and an over 2 here. That gives you 2 pi times L times R1 plus R2 over 2. And the idea here is this gives you the average of the 2 radii, and also it makes 2 pi appear, so this sort of makes it look a little more like we would expect an area formula to look. So that is what I should have done in class today.